Hi guys, just a quick word about this one before we watch the video. This is probably a very good example of where you are likely to be able to fix something without a schematic and where you probably can't. You probably need the schematic. So watch it through to the end, see what you think. Yeah, we can chat there. Hi guys, welcome to Learning Electronics Repair. And I have an amplifier to repair here. This is from Power Sound, local company here in the south of Gran Canaria. Not the same company that's been bringing me all the other work in on amplifiers. Sonny Yada and their nightclub, to CTO, yeah, not those guys. So he called me, or rather text me, said I have a faulty amplifier, can you have a look? Didn't tell me anything else. Said I'll send the lads in. He sent his wife in, and here it is. So it says paparazzi on the sticker, not coming out the camera, but it says izquierda and derecha, which means left and right, and that's about it. I know there's a restaurant up in Las Palmas on Las Canteras Beach, basically on the promenade, called Paparazzi. Italian and similar, do burgers as well. I don't know if there's a local one, so I honestly don't know if this came from the capital or whether there's another Paparazzi. Probably quite a popular name, really, for businesses. Usually Italian. Okay, so this is the amplifier. I know nothing about it. How do I proceed? Well, I could just plug it in, put the current limiter on, which would make some sense, and see what it does. Or I could take the lid off and have a quick look to see what's inside this, what state it's in. And I think I'm going to go with plan B. I mean, if you are trying to restore an old car you found in a garage somewhere, or you're going to try and start it, or you're going to have a look first, see if there's any oil in it. Yeah, that's my theory on this. So all of those who would try to start it anyway, well, you're not going to see that on this video. Okay, so let's get the lid off and let's have a look to see basic checks, short circuits, anything that looks burnt, and we'll go from there. Okay, well, that's interesting. Bit of plasticky cardboard to insulate the heat sinks. Okay, so let's see, what do we have? It's a stereo amplifier, 2 channels. It looks like there's 2 sets of heat sinks for each channel. I think this will probably just clip off. I think it's just held on with some sort of clip down here. Then we can get a good look at this. Yeah, just some clips. Okay, the clip's intact, it stayed there. Can we get this side out also? Yeah. So it's nicely marked, channel 1 plus, channel 1 minus, channel 2 plus, channel 2 minus. Okay. A linear power supply, of course, large capacitors. This looks like the voltage supply here, coming over to the amplifier. There's 4 wires, but I'd imagine this has a plus and minus, whatever. That looks like probably a speaker output. Yes, a CH1 byte. Just zoom in a little bit. Yeah, CH1. So this one, yes, CH2. So I think this is the power, and this is probably a 15 volt supply rail as well. There's usually a 15 volt plus and minus there. Okay, this is all stuck down with some sort of glue. Not sure what these are. I don't think they're fuses, but can't really see. Right, so first thing then, I can see some markings on this. Oh, I see. So this has a voltage low and high minus, voltage low and high plus. So this is a class G or H amplifier, which has the dual supply rails. We can see them clearly now. Plus 24 volts. switch 1, switch 2. What else is it saying there? AC, need to get a torch down there, which might help it to focus if I can just get in there. (24 volts). Switch 1, switch 2. Delay. And plus and minus 25 or AC 25 more than likely. Okay. Again, just awkward to see down that little bit because of the heatsink in the way. Yeah, AC 25 volts. So we basically see what we have. First question then. Do we have shorts in any of the voltage rails? We need to find ground. So ground will be on one end of the speakers. I would say it's not a bridge. Could be wide as a bridge, I guess. Don't see anything there. From this one. Don't see anything there, but almost certainly there's going to be relays. Yeah, I can see the relays under here, which effectively disconnect the speakers until the circuit powers up and the protection detector works and tells us there's no faults, and then it connects the speakers. Still, where is ground? Well, obviously the junction of these capacitors would be ground. I just need to find where that is. You would think that goes to a center tap on the transformer. Looks like the chassis is ground. Yeah, which connects to the negative end of the speaker. So I'm connecting from the chassis here, negative end, so that's ground. I don't see any switch to put this into bridge mode, unless we have something here. Oh yeah, we do have a bridge mode switch, but at the moment it's just set into stereo. Okay, so fine. Right, we know where ground is. In stereo mode, the negative end of both speakers would actually connect to ground. So we know where that is. Now then, do we have any shorts? So this is the negative voltage rails. That's climbing up nicely. Sorry about the reflection on the meter. Climbing up nicely, and then we have the positive rails. Well, that reads like, I was going to say it reads like open, but a bad connection. It's climbing up nicely. Same with that one. So I don't see any shorts there. I'm just checking between voltage low plus, voltage high plus. Looks like a capacitor charging there. One way round, I would expect to see possibly a diode here. Diode junction. Let's have a look. Just charge the capacitor the other way. Yep, gone through 0. Does this stop with the diode? Yeah, you would expect to find that on a Class G amplifier. So let's look at the negatives as well. So in one direction We see a diode, okay. And the other direction should just climb up, which it is doing. Now the way this Class G amplifier basically works is you have the two voltage rails, V plus high, V plus low, okay. And you have V minus low and V minus high. Your output stage of your amplifier is wired like this, some low value resistors, okay, and then this is a PNP transistor, like that basically. Your speaker connects from here. When you're not in bridge mode, it connects to ground, which is what we're seeing. And then you have another transistor in here, NPN, or there could be MOSFETs, okay, wired basically like that. And you have another PNP in here, wired basically like that. Now the idea of this is the circuit monitors the height of the waveform, and if it's approaching the supply rails, let's say this is a low voltage one, let's say this is something like plus 35 volts, minus 35 volts, and this is something like plus 70 volts and minus 70 volts. If the waveform is reaching the limits of here, it's going to go past that. It switches these transistors on so that the amplifier is supplied from the higher voltage rails, okay? But what you don't want is the higher voltage rail, when this transistor is switched on, going back into the low voltage rail here. So what you have is, you have a diode there, which won't conduct in the reverse direction. And the same applies, you have a diode here this way around, okay? You may well, and probably will have actually, a diode here as well, and I didn't even leave enough space to draw it, but you'll have one in here as well, that way round, okay? And this is just to keep the two voltage rails separated from each other. Now, we're seeing a diode junction from here to here, and we're seeing a diode junction from here to here. It could be a fault condition. It could be a fault condition. So if this was short and there wasn't a diode there, maybe we're actually just seeing that diode junction if we had a short here. But it's a little bit suspicious, so I'm going to take the main amplifier board out first and have a look for shorts on the output devices and these components which switch the voltage rails. These are the most likely things to fail anyway, so it's a good idea. But that diode junction that I just showed you kind of indicates we might have a problem, because really you shouldn't see anything between there and there if we have these two diodes, or if we only have one diode and that transistor is switched off. You shouldn't see it. I've disconnected the wires now. We can have a look again, so we can just check. And it's probably easier to do it this way. Unplug that and plug it onto here. Whether those diodes we see are back on this board, they may be. They might well be. May not be a problem. We will find out sooner or later, no doubt. So let's have a quick look now in diode mode. No, it reads open that way, back the other way. Reads open. So whatever we were reading was actually back on the power supply board. We know the capacitors were there anyway. Yeah, nothing. Okay. I'm not so worried about that now for the moment. I might as well take this off anyway since I've disconnected it, and let's just check the shorts in the output devices, although I suspect we might not see any. And then let's try this. Okay, so we can see some big diodes down here. We can see 2 large power devices and 2 smaller ones. And we can see that's also on here as well, 1, 2 and 2 smaller ones, the same on each channel. Okay, let's just check them. This would be the base or the gate, and probably the same on those as well. So if this is the base, and they could be MOSFETs. Well, that reads open, that reads almost short, but expect to have quite a low value base emitter resistor. Yeah, 16 ohms, so that's basically reading what you might expect. So the other way around, this would also read nearly short, and this should be diode junction PNP. Collector emitter should not be short. That actually reads like a diode in that direction. These could be MOSFETs, but the low value resistor makes me think they're probably bipolar. And bear in mind that this is the PNP, so the emitter is going to be positive with respect to the collector anyway. In normal use, that reads okay, pretty much okay. Again, the low value resistor. So this NPN, again the low value, and with the collector positive we read open. This might be like a diode. Okay, same with this one, no short there. And then we have the same for the other channel, so depending which way around they are. Yeah, that looks like the NPN. Looks like the NPN, and then this will be the PNP. Yeah, the low resistor. No conduction with the collector negative. Same with this one. Base emitter reads low, and this reads a junction, so they read okay. These will probably be the same way around. So diode junction, lowish value, remember it could probably base emitter, reads open, same. Well, this looks like it's NPN. Yeah, you expect that probably. Reads okay. So on this one, that reads like a low value, whereas it doesn't the other way around on this one. Let's check the other one the same. So that looks like probably the same as this channel. Yeah, and that low value, so they look the same as each other, so that seems quite reasonable. Okay, complementary one, this channel, opposite to those two. Looks okay, and that lowish value again. This doesn't have the lowish value. Okay, and then the last one over here. Yeah. Okay, I mean that all looks okay as far as those are concerned. We can just have a quick look at these things. What are these? This looks like 2 diodes in series basically. As does that one. Seems to be complementary in some way. Again, they all look about the same as each other. Sorry about the glare on this, guys. You can hear it though. No obvious shorts there either. Well, we can see these two are RM08 and RM010, but they are both RM010, and this is a voltage regulator, 7824 24 volt voltage regulator. Not sure what these things are, RN08 and RM08 and RN10, but we can have a quick look. Well, a quick look around suggests that it's these devices on semiconductors, the right manufacturer, high voltage power transistors. So not the other part number, but they say J340G and J350G, which I think is these. The package is correct, the manufacturer is the right one as well, so it sort of makes sense. So I don't see any shorts in those either. Well, I don't see anything specifically a problem with this, so switch on. There's a little thermal trip on the back, but there isn't a power switch on the back. I have the light bulb connected over there to limit the current it will draw. You can see the front panel, you can see it in the amplifier as well at the same time. Let's power this up and let's see what the bulb does. Well, bright and then dim, that's not a problem really. And then less bright the second time because the capacitor's already charged up. So we switch that off, power it up, power is lit up. Everything else is off, fault is off, clip is off, signal is off. I heard the relays go click. I'll connect my speakers to this and with a signal. Let's see what this does. Oh, actually, before I connect my speakers to this, I want to have a look to see there is no DC offset on the speaker terminals. Now, the fact it doesn't go into protect mode suggests that there won't be, but we better make sure. So again, power up. Power is on, and we'll check the power rails as well, I think. So this is one of the speaker outputs, no voltage across it, good. Other one, good. Power rails, so this is minus 74, about what I expected, minus 37, plus 37, plus 74 then. So they are all there. Okay. I also have a ground and plus 24 volts here on this connector, so we can check that. Just make sure I have a connection, switch the resistance range. Yes, I read something. So this should be the plus 24. Nice. And I should see AC 25 volt between these two. Well, actually it's AC 50 volts. It says AC 25 and AC 25. Maybe in actual fact that's with reference to ground, so we have a plus and minus 25. That sort of makes sense. I see 50 across the two, so I'm okay with that. Now I will connect the speakers, because whatever's wrong with this is not like an obvious problem, okay? Okay, so let's see. As usual, a bit of Northern Soul. Switch it on. We have signal, but we have no audio. Oh, okay, so the problem with this is we see a signal when there's a signal coming in. Just turn my mixer down. There it goes out. So we have signal on this, but we have no audio output. So that's the fault on it at least. Okay. Another thing I noticed with this, and I don't know if it's relative to this or not, but the fans don't work either, okay? Okay, what I have noticed is a switch on the back here on the input that switches between 1.4 volt and 0.775 volt. Now that was in the 1.4 volt position. So I've moved it to the 0.775, which it did, but I can't move it back again. See this switch here, this moves fine, okay? Bridge, parallel or stereo. But this switch doesn't work properly. Now, that may be something to do with why these inputs are not working. I'm not totally convinced, but we need to look at it. Because we have a pin on here which says 1.4, 0.775, so that must come from that switch. We have a plus and minus 15, so we can test those voltages are present. We have, well, BR plus, BR minus. That might be the bridge thing. LED, ground. Can't see anything marked on these, but this is marked 1 in. There's a blob of glue on it, but I think it's 1 in plus and minus and 2 in plus and minus. Maybe. It only seems to refer to the first 3 wires. Comes off. Let me just see if I can get that glue off there. And maybe heating it up would be a good idea, but obviously I don't want to melt the connector either. Can I get this off? No. The other possibility is to find a schematic. Now, on the front there says XLi 800, but on here it says XLi 2500. So possibly one of those two numbers will lead me to a schematic. Ah, this comes off. Okay, so now I can see much better what I have here. We have 1 in, ground. Come on, show me what's under here. 2 in. Okay, so I think what this is doing, because they haven't got the space, so they're saying 1 in minus 1 in plus, ground, 2 in minus 2 in plus. So I'll have a quick look for a schematic, but if I don't find one, I can have a look at the signals here and see if I actually have a signal getting into the amplifier. May well be that switch is the problem, the one down there. Well, this is the input PCB. So I've taken this off the amplifier. We can see the connectors here. And this is the switch. And look, it's now moving again, but that is not particularly good, I don't think. Problem is, do I have one that has the long thing there, yeah? You see what's happening if I try and push it from there, and I could only see this piece sticking out from the back. I'm not actually getting any movement. What's a corrosion? I'll unsolder this. Let's see if I have one. I mean, I have some salvage slide switches, but I don't think I'd have one with a actuator, can we call it, like that. And this is very difficult to use on the amplifier. Literally, I can only see that bit. I can't see the other bit. But maybe if I can get a good contact, if I can't find a switch, I can at least prove that that's what's causing the lack of audio. I mean, it might not be this, you know. It was in that position. It was only when I tried it, and I did manage to move it that I couldn't move it back. Anyway, enough talk. Let's unsolder it. It's actually bent the pad a little bit. I can see, by the way, this is just wired in parallel with both sets of switches. It's not a double pole switch, or rather it's not used as a double pole switch, it's used as a single pole. Double throw. Okay. Yeah, you can see that on the PCB. Let's see if that's now free. Yeah, you can see all the legs from the switch contacts are actually moving, so they're free. It's just the metal frame that's holding it in place. Let's see if I can just release that with a soldering iron. Yeah, it's coming. Okay. Yeah. This leg is just holding in place, but quick touch of the soldering iron, that should come out. There. Okay. I had a look around. I don't have any salvage ones like this. I had a quick look on AliExpress, and I struggled to find the ones that have like the single mounting bracket at the end there. They normally have like 2 of these tongs on rather than just 1, and with a long enough handle like that. Yeah. So I'm going to stick this back on. I mean, I know electrically it is good. I'll put it back in the position it originally was, and I won't mess with it. And let's see if that actually was causing the problem. But the fact I have a good electrical connection makes me think it probably wasn't. Okay. It needs changing, but it's a matter of finding the replacement one. But I suspect we've actually got a different fault on this at the moment. Okay, that's nice and clean. So this is in the up position now, which was the position it was originally in anyway. And we can just check, and we have a good connection, and this is open. Okay, so we know it's good. Let's see if we can figure out, because I suspect it still won't work, what's going on, because we have some test points here. We have some ins, we have some voltage markings, the plus and minus 15, so we can make some tests. I've connected a signal generator, well actually sound card on the PC with an online tone generator, so I have a sine wave coming in. I'll just check for the voltages first, and then we'll get the scope and see if we can see the signal. So down here we can see plus and minus 15, which are essential basically. Yeah, so we can measure the plus and minus 15 on here. I see a 24 volt test point as well, just there, so we can check that one. And if the voltages are there, let's see if we can see the signal. So we'll power this on. And something's changed straight away, so switch it off again. For some reason now the fault light is on. Okay, that's interesting. I mean, I've only had that thing unplugged, put it back on again. Yeah. Let's take the signal off. So I have this signal coming in, but my mixer is actually turned down. The mixer's turned down. Okay. What are we having here? So you can see the amplifier there. I'll put the current limiter back in, but that's behaving normally. And I now have the fault light on both channels. So something's changed. I wonder what. Okay, I've disconnected the speakers. Both fault lights are on, the light bulb is dim. Well, that's interesting. I wonder if I didn't have a good connection on here when I was testing it before. Let's see what voltages we've got. You don't suppose that switch, now it's obvious, I mean, we know the switch is working now, wasn't before, something stupid, and we now have a different error. I don't know, I'm not sure. Okay, what voltages can I see on here? So minus 74, minus 37, plus 37, plus 74, they're all okay. Let's go on to these. So 24 volts was here, was good, and then the plus and minus 15, plus, minus. The voltages are all good, but I have the fault LED on now, on both channels. Look at the, there's no point where you look on the speaker output because this should be disconnected if there's like some error. Yeah, so the relay should disconnect that anyway. Right, let's see if I can find a schematic for this now because something has changed. I'm just wondering if maybe, because I had this thing unplugged before, it wasn't pushed on properly and therefore the high voltage wasn't on the amplifier. So I'll let the voltages kind of like go away and I'll try maybe without that connected just to see if it then behaves as it did before. Obviously no audio, but I had a signal. I am seeing something a little bit odd. I'm not sure this is at all relevant, but this is high voltage plus, and this is low voltage plus, which would be slightly negative now. And this is low voltage minus, which reads slightly positive. And this is high voltage negative. So for some reason, the low voltages are reading like the opposite polarity that you'd expect. It's a bit strange, that. I've disconnected this just to see whether that's why the fault lights didn't come on previously, because I thought I had that connected properly. This seems fine. This is good. This is good. This is good. Let's see. So we'll power this up, and there's no power to the main amplifier now. And the fault light comes on. I hear the click. I have the fault light on. Obviously there'll be a lot of voltage in the capacitors now. It probably won't discharge either. Let's have a look. So 60 volts plus, 30 volts plus. So we're not getting this funny minus thing anymore. Minus 30, minus 60. Okay, it would be nice to let them discharge, to be quite honest, before I plug it back onto the main amplifier. Although having said that, it didn't do any different when it was connected. So you can see after several minutes these are still holding a charge. I could discharge them, but when I did power this up, the light bulb limiter came on and went dim, so this wasn't drawing much power anyway. So the chances are, if I just connect it back on, it will just discharge the capacitors. We're going to find that out right now. Yeah, so basically the lights came on the front and went off. So there wasn't like a flash and a bang. It's not like anything on here is actually drawing a lot of power. So with the amplifier power connected back up again, I'll put the camera on the light bulb so you can see exactly what's happening here, okay? So there it is. It's switched on to limit. So if you watch the light bulb, and you can see what's happening on the front panel at the same time. See, bright then dim, and the fault lights are now on. So whatever has changed, something has changed. The only slightly odd thing I see is why these are discharging because there's a load, not a short though. Why these go to the wrong polarity? See, so it's going down towards 0. This is the positive supply. Let me just get the camera on it. Yeah, this one, positive supply. It was going negative. So the high voltage one is still 13 volts. Give it a little while, see if it goes negative again. Here we go, it's down to 0. Look, you see, that's odd. And this is going positive. Where does that take us? Well, there's no shorts in the output, I'm sure, because you saw what happened. It doesn't draw a lot of current. Those supply rails were behaving a bit odd, and these go through the switching circuit on here to effectively select the high and low voltage. And there were some diodes in there, I showed you that, and the reason I'm seeing like an opposite polarity, it might be normal behavior on this amplifier, but it seems a bit strange to me. I see minus 0.4, and it's about the minus of a diode junction. Look, 0.416 plus and minus 0.417 in the opposite polarity. So this still has 10 volts roughly, plus and 10 volts minus. That's strange. Okay, let's get this board off again and let's investigate a bit further. See if we can figure out where those switching transistors are. Okay. I would have to assume, because there's nothing else I can really assume, as there was a problem with that switch originally, and now that's operating correctly. I can see the other fault. That's the best I can come up with. What about you guys? Can you come up with a better idea of what's changed other than that? Once again, in diode mode, we check the power component. So we know this end is the base or gate. It looks like this board is designed to have like another set of transistors. You can see we can have there and there, which are not fitted, the same here. The board, as I mentioned before, XLi 2500. The amplifier says XLi 800. I'm guessing there's different models of this, higher powered with more transistors fitted, but the PCB is probably the same. I can't find a schematic for this. I found a schematic for the XLi 3500, but that doesn't match any of the numbers. So maybe that isn't the same. I couldn't find anything else close, either looking for XLi 2500 or 800. So I'm a bit on my own with this one. Let's see. So we know this as the base end, and we have a low value resistor, base emitter, which we can see that. This reads like a PNP transistor, and there's no reading between collector emitter with the emitter positive, because obviously that is the way it would be in circuit normally. This side probably a diode junction, we see something else in the circuit, so that reads good. This one, the low value resistor again, which I think are these resistors. You see them here, 15 ohms. Oh, in fact, you can see that's where it's connected. That's why we see that base emitter thing. Okay, same reading. So again, junction looks okay. Doesn't read anything. Reverse polarity looks like a diode. That's okay. So that again are okay, and the same with the drivers. I think one was NPN and one was PNP. So that reads like a PNP again with a low value resistor, or lowish value. That reads as you'd expect. And I think this one was the other way around. NPN, the lowish, NPN, so there's no lowish value resistor on this one. And with the positive to the collector, reads like open in this reverse direction, probably like a diode. Or maybe open, we'll see. That reads open both ways. So that looks fine. Now that's a negative channel, and the other negative channel is this one, so let's do this one next. So the low value resistor, base emitter, that reads open. Is this the negative channel? Is it this one? They're marked. Okay, so the first one I was doing was channel 1 plus. So the other one is actually over there. So this one will read the same as the end one. Okay, I had it the wrong way around. Yeah, this is a low value resistor. This reads open. This reads like a diode. Okay, same again with this one. Low value resistor. Okay. Open like a diode. And then the two at the end here, this was the PNP one. And this read like a lowish value. Yeah. Nothing that way. Diode this way. Yeah. And then this one was NPN. We don't have the lowest value resistor. Okay. Okay, and then this reads open both ways. So those two ends channels read the same as each other. Then these two are effectively identical to each other, opposite polarity. Diode junction, the low value resistor, with a positive to the collector, because this is an NPN. No diode junction, reverse diode junction. Okay, same with this one. Okay, lowest value, nothing, like a diode junction. So that reads okay. And we know these resistors are okay as well, because while we're measuring the transistors, we are effectively testing that. These might be the opposite way round to the other. Yeah, there's the lowish value, reads open. And then this one will be the other complementary one. Okay, no lowish value resistor, reads open. Okay, a little bit messy. Let's just have a quick look at that. It's like a bit of the lacquer has come off here by the looks of it. Yeah, this looks like flakes of that like coating that we have. Somebody worked on this before, it's possible. This could actually be old flux. I'll clean it in a minute, but I don't think that's the problem at all. Yeah, it looks like either it's flux from manufacturer or somebody's worked on this before. We'll start with these two. So I think this one was the NPN on this channel. Yeah. Yeah. That lowish value reads open. And then this one's the other complementary one. So black to the base. Yeah. No lowish value on this one. And open that way. Okay, so that's good. And then the two output devices on this channel. Sorry if I went off shot a little bit there, guys. I'll zoom out a little bit. Okay, so these are the NPN, the low value. Reads open that way, like a diode the other way. The The last one. Bit laborious this, guys, but you have to do this, yeah? You have to do this methodically. Yeah, the lowest value. Open and then like a diode that way. So all the output devices look okay. As before. There's some hefty looking diodes around here, so again they're on each channel, so let's check that. Reads like a diode. I think this is this way round. Reads like a diode. Reads like a diode. Another one here. Reads like a diode. So they all read like diodes. And then up here we have 4 across here. Oh, other polarity. Diode. Diode. These might be the diodes we see across some of the transistors in the reverse polarity. Diode. Across collector emitter where I was looking at them backwards. Is it the other way around? That one that reads open. Yeah, diode. So that still looks okay. I expected that because I didn't have the light bulb coming on bright. And then we have this lot, which I can only assume is involved with the voltage switching between the high and low voltage. We had that strange effect we could see where the low voltage plus and minus effectively go reverse polarity as the capacitors discharge on the power supply. I noted when I looked at this before that they're in a bit of a strange order. So that one is a 24 volt regulator. Yeah, this one. So 78M24, 24 volt regulator. And we know we have a 24 volt supply on this. These are complementary, NPN and PNP. We had the data sheet. I'll check the readings on these again because I wasn't sure what I was reading before. And these ones are both the 340, which I think were the NPN. Yeah, these ones. So we have 340 is the NPN and 350 is the PNP. So NPN, voltage regulator, NPN, PNP. Okay, by the looks of it. These two are on different power rails. You can see that, like the big area here, big area here. This one on its own, it's the voltage regulator. And then these two are in parallel. You see that they're on one big pad. So those are both in parallel. Now, how do these all look? So base emitter, that reads like a junction. And collector, that reads like a junction as well. NPN, so positive to here. Well, I get a reading which goes away. Same, base collector, base emitter, positive to collector. Yeah, nothing. And then this one should be the same. Yeah. Well, that with the positive to the collector, that's like a 0.6. I wouldn't expect to see that in that polarity for an NPN transistor, because normally the collector is positive with respect to the emitter, and something's stopping this going more than 0.616 volts above that one. And this one should be a PNP. So yeah, I see the two junctions, and being PNP, the collector would be negative with respect to the emitter. And I see that again. And that opposite way reads that. There's something, to me, a bit strange about the readings around them. We have some more big diodes here. Check these. Reads okay. reads okay, reads okay. So they're okay. There's something a bit odd about the readings here, just trying to think. So I could remove them, but I don't think the devices are faulty. I think they're okay. I think there's something. What's this? 1 ohm resistor. A 1 or a 10 ohm? Ohm resistor, and that goes on to here. So this is Q9, this is Q3. Let me have a look at the schematic I have for the 3500 and see if that in any way is basically the same as what I'm having here. Well, this schematic is not the same, or even close, I think. If you look at this one, this is your main amplifier here. This is your amplifier, audio in, amplifier. So these are your 2 channels. These are all your output devices. That's 4 output devices. You can see them there. Or is it even 5? No, this one's driving all those 4. So there's 4 output devices per channel. And the other thing this has, interestingly, although it's like a class G amplifier, it actually has 3 voltages. So you have voltage low, positive, voltage medium, positive, and voltage high, positive. So look, you can actually switch the supply rail here to any of those 3 voltages. And of course the same with the other side, there, look. Okay. This is your minus side with the 3 voltages again. So all that selection circuitry is completely different to mine. The only thing I have to go on at the moment is there seem to be some strange readings around these. Right, guys, I had to have a bit of a poke around this. When I find something a bit unfamiliar like this, I have to kind of work it out for myself before I can explain it to you guys, basically. So this doesn't particularly get me anywhere closer to fixing this, but I do at least know what this stuff is doing now. So this one, the 24 volt regulator, we can say with good certainty generates the 24 volt supply. We have on here, and we know we have it, there's a test point there just below this slot in the board. Okay, so we can see the test pointers here. The output of the regulator will be on this pin, and that indeed goes to there. So that's your 24 volt out. Okay. These 2, if you look at them, I just took some educated guesses and I got it right pretty quickly. The collector of this one goes, that's V minus low, the 30 odd volt supply, okay? And the collector of this one, the complementary, this is the NPN, goes to V plus low. So that's where they go to. And they're fed via a 10 ohm resistor, so they can't be handling a huge amount of power. The fact we're going through a resistor kind of limits the current. The emitters of these go this way. This one we can clearly see where it goes to. It goes to this component. And the other end of the component is connected to ground. Okay, so that goes to there. The other one actually goes to this end of this component, and again this goes to ground. So those components are actually 2 capacitors here. And if you think about this, if we have a minus supply coming in on the collector and we put whatever voltage onto the base, we will get a voltage 0.6 volt different, roughly 0.5 volts on the emitter. So this is an emitter follower. It has a capacitor on the output, so this is a power supply for something. and the same as that one, negative and positive power supplies. And my guess from that, and it was a guess and it was a good one, is that this is the plus and minus 15 volt, because we know we have them and they're on here. So if we go here, that one, that is the plus 15, and that one is the minus 15. Now, we know the plus and minus 15 are there. So whatever reading I'm seeing around here is not strange. Yeah, is not strange. It's probably because I thought the emitters were going to ground and they're not. The emitters or the out. These are series regulators basically. So now I'm not concerned about that. These two are in parallel and they're generating some of the voltage rail on here. I'm not totally sure which one that is. They may be generating these on the emitters. Might be series regulators again. So let's have a look. So if this is the input, just a guess, it's got to come from, well, it doesn't come from any of those. Oh, it comes from here. No, it is a diode to there and to there. Okay. What are those two? This is plus some. This is just 25 volts AC. Okay. So this AC 25 volts we have there feeds into this circuit. Okay. I was seeing a diode, so there's a diode down here somewhere before it gets to there, but that's where those are going to. And this is generating some other voltage on the emitters, which are connected together. What else do we have? Is it the fan? Wow, the fan connectors are here. Oh yes, Luke. So this is your fan control. It's a variable voltage for altering the speed, or at least it's switched. So that's fan control, that's your 24 volts, there's your plus and minus 15. So that is nothing whatsoever to do with switching the voltage on the amplifiers. Yeah, nothing at all. Which, because I can't see anything else that does that either, and this is not particularly high powered, I'm thinking now I have it completely wrong and this is not a class G amplifier, it's a class AB. And just to really confirm that, this is your plus supply. You can see that goes there, not to that one, it's the other end one. That's your positive supply. This is your negative. So these are your high voltages, your 70 volt supplies, plus and minus. And then we have the output transistors. Now this is wired not quite how you would think. So you would think the positive rail would go to the collector of the NPN ones, and then the emitter of this would connect to the emitter of the PNP, and then the collector would go to the negative rail, and it doesn't. How it's wired up is from the positive supply goes to, well, that's the base with the low value resistor. The positive supply goes to the emitter of the NPN, there and there. And then the collectors, which are connected to each other, go to the collectors of the PNPs, and the emitters of those go to the negative supply. And then the collectors are all connected together, as we know, and that'll go to one of the speaker outputs. That one. And then the speaker output from the other channel will go collector, collector, collector. Now, that doesn't make so much sense. So I'm thinking, and it's hard to see because of these clips which hold these on. You'd have to get the entire heatsink off, which I could unbolt. They look like bipolar transistors. I was thinking maybe the MOSFETs, but I don't see that being the case. So I think this is just a bit of an unusual topology. I don't see any reason why it couldn't be that way around, but I think when I was looking at these plus and minus channels before, I was seeing the wrong polarity on the transistors. So channel 1 positive, you would expect to have the NPN transistors. Yeah, the positive side. Are these the NPN? Base. Positive. That's the low value resistor. No. These are the PNP. Right, so what we seem to have, and this doesn't really help me to fix this at all, but I'll show you guys because you might be interested. We have an amplifier output stage like this. So we have a plus 70 volts. Yeah, that's going to the emitter of the PNP transistor. This is your collector. Base. We know we have a low value resistor from the emitter to the base, and that's then going to the collector of the NPN transistor. This is connecting to the minus 70 volts, and then it's like that, and your speaker goes here. So somewhat back to front to how we would normally see. There might be low value resistors in the emitters, didn't really look. But there were some big resistors down here by the side of this one, and I can see them in the middle there down by that one, so they're probably behind these as well. Just can't see where they are easily. Low value resistors maybe. This was like a 133, it's got a silver band on it. Yeah, 0.3 it looks like. Oh, yeah, it's not 133. Look at that for a colour code. Yeah, look at that. Black, orange, orange, silver. So that's the emitter resistors. Can you see them? Look, 033. Yeah, and then the silver is times 0.01, I think is silver. 0.1 is gold. Yeah, so it gives you 0.33. I've never ever seen in my life a resistor colour code like that. Black, orange, orange, silver. 0.33. How about that? So from that, although we can't get to the other side, we know where they are. Emitter resistor, that's one. Oh, the other one's off down over here. Not sure what that is, but it's going to go out the way it's gone. Didn't like it. So, emitter resistor, then there will be one here. Yeah, 0.3. 0.3, and then we'll have two on this amplifier and two on the last one. So 0.3, 0.3, and lastly 0.3. Okay, so all the emitter resistors are okay. They're actually here. Okay. .33 is kind of thing you'd expect. I mean, normally between about 0.22 and about 0.5 is what you would have, so it makes a lot of sense. So that's how the output is connected up. And this comes to the question from the start of the video. So this is, when do you continue to fault find something, or when do you really need a schematic? In the case of this amplifier, we have no shorts in the output devices. I figured out where all the voltage rails are coming from, and we know they're all present. So we know what all that lot does. We know the fan isn't running, but it's temperature controlled anyway, and we can see where that is coming from as well. So all the voltages are okay. The light bulb is doing what you would expect it to do, even though all the protect lights are on now. The reason they were not on previously, I'll have to put down to that switch, but it's hard to say. And I think even you guys will think that was hard to say. So it looks to me like we have the type of fault here whereby there's nothing actually wrong as such, but the protect circuitry thinks there's something wrong. Yeah. And that probably brings us into this lot. Yeah. Or maybe this lot. There's a load of circuitry down here as well. By the end of each amplifier module, yeah, there's a lot of stuff here as well. So this is probably what is monitoring the condition, and somewhere in here is a bit of logic. They're probably op amps actually, rather than digital logic. But given on whatever it sees from here, it will put the protection lights on. Yeah, I think the fault is in that region. Now, I could first make a physical examination, which I'm doing because that's easy. Don't see anything burned. See plenty of transistors and other components. Okay. It is a little bit blurred at that magnification, guys, but I don't see anything obvious. Same in here. Nothing obvious. So generally, when I started this, I was hoping to find, you know, something to say, yep, that's it, get some parts. At this point, I hope you agree with me, but at this point, it becomes a much more in-depth repair, which means more expensive, and without a schematic, maybe difficult. I could get lucky, and these circuits kind of look like that's the same as that, and that's the same as that. Yeah, can you see that? And we know we have the two positive halves and the two negative halves, so that makes sense. So I could get into this lot. In fact, you know what? Let's do it. But if I don't see anything obvious, then this is not going anywhere without more information, I think. So what I'm looking for here is basically differences. Do I see any major difference? So looking around the diodes first. Let's go into diode mode. I don't want anybody to accuse me of being lazy, okay? Although I am at times, I admit it. That reads okay. Reads like a diode. Reads like a diode. I'm trying to think. This looks like it's part of that block to me. Could be one of these resistors, because these are high powered resistors, probably taking some high voltage into this lot, which is monitoring, and that's a possibility. One's gone high value. That would probably cause this sort of problem. I'll stay in diode mode for now. I'll come back to them in a minute. Another diode here, and then these what look like transistors, could be MOSFETs. That kind of light just reads open that way, and like a transistor that way. We can see the same one on here. So this looks like a PNP transistor. Again, do it the easy way. Looks the same. Diodes. We know the others looked okay. Looks okay. Looks okay. Looks okay. And then 3 more transistors. Ah, that reads like a short there. No, it doesn't. I was just touching that component next to it. Looks like a diode junction, okay. Looks like a diode. So these are kind of the other way up, just to make it a bit more difficult. So I'll look for any shorts, I think, here. And it's possible some of these might be double diodes or single diodes in this package. See, that one reads just like a diode there to there. Okay, do I have to see the same on one of these? I see the same around that one, so that makes me think they probably are the same. Okay, yeah, this is the same way up as that. So those basically look like each other. Let's look at these high value large resistors, not so much high value, high current. So these are 220 ohms by the looks of them. That reads 218. These are quite a likely failure actually in this little circuit. That's that one, that one. That one. That one. 22 ohm. 4.7 ohm. Looks close enough. 4.7. Close enough. My meter doesn't exactly zero properly. 22. So those basically look as okay as I can say, to be honest. Another one here. Another one up here. We looked at those. Those are the base emitter resistors. Okay. So I don't see any real issue there. And then I have these two channels out here. So back into diode mode. Okay. Diode. 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 Should find the same over here. Looks like it's these three. Fit it the other way round. Diode. 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 Okay. Then I have another diode here. That one, which will be the same as this one. Okay, then I have these set of 3 transistors. So the middle one is probably like those, and probably is a diode. Yeah, you see that? Just reads a diode junction there and nothing else. So that'll go the same as that one. And then we have 2 transistors by the looks of it. All the way around. Diode junction. Diode junction. Diode junction. Diode junction. And then from this one, this way round. Diode junction. Diode junction. Try all the way. Diode junction. Yeah. Okay. Again, guys, nothing obvious there to go by. another problem with this, even if I have a schematic, I probably need to measure quite a lot of voltages, and I can't do it while, excuse the meter, I can't do it while this is in the case. Yeah, I'd probably have to remove the power supply PCB from the case as well and fix something up so I can connect power into it, and then literally get us on the bench upside down and do it that way. Yeah, and the same with our little input board as well, where that switch was. So that's another consideration with this, and all this pushes the price up. So I'm gonna have to speak, A, you guys, can you find me a schematic? I couldn't find one. I'll have another look myself also. And B, the customer, because I'm going to say, Luke, this repair is going to go over 100 euros, I would think, or about something like that, depending how much more I have to investigate. With a schematic, it will be easy. Without a schematic, this would be extremely difficult, I think, due to the nature of the fault. Although, you know what, could be just something obvious that I missed. Well, there you go. Okay, so there we have it. You can see what's what with this one. I've repaired this type of fault before. It's all supposition, of course. I had similar problems where there wasn't anything basically wrong with the amplifier. The fault is somewhere in the detect circuit that makes it think it has a protection fault. And this appears to have all the symptoms you would expect to find that support that theory. Okay, so that's my take on this one. And as I said at the end of the video, I've just added this epilogue on. I think this is the kind of situation where really you do need a schematic, and with the schematic it probably wouldn't be too difficult to fix, but without it, well, maybe I need a 4 AM moment. Yeah, maybe in the night I'll think, I should have done this, and then there you go. Okay guys, so the 4 AM moment, what did I think? Well, two things. One is that when I disconnected the power, the red, black, grey and white wires, that's the high and low voltage plus and high and low voltage minus from the amplifier board, the fault LED still came on. So I've disconnected this. At the time I didn't know that the 15 volt plus and minus is derived from there. I know now. But they still lit up. So the only way they could have still lit up is if they are somehow being powered from here. Another thing on the same sort of topic is one of the pins on here is marked plus 24, but we know we have a 24 volt regulator on here and plus 24, but that would say that the plus 24s are not the same plus 24, if you see what I mean, because only that plus 24, or the thing that generates power for the fan, which seems very odd, could have been lighting those red LEDs. So it doesn't help fix, but it does make for interesting thought. Oh, it is the same. So that plus 24 looks like it goes back onto that board. Maybe. Well, anyway, that's that. So that's the only way I can think that the red LEDs would light up, because you've got a supply, and the only supply I can think is plus 24 if it's coming in this way. Go figure that one. Okay. The second thing that I thought about is there's another reason why this might not be working. This could help to fix it. So we know there's no shorts in the amplifier. I've checked all the power components and a lot of other stuff. Can't find anything wrong. Had a look at the circuitry as best I can, that I think is part of the protect circuit. Can't see anything obviously wrong. But what could be happening is the op amps, which are down here, which will be feeding the signal in from the input. If there's a fault in there, such that it's putting a DC voltage onto in 1 or in 2, yeah, plus or minus. Then because this is a DC coupled amplifier, if you put a DC voltage on the input, you will get a DC voltage on the output. Yeah, that's why we have the protection. And I did mention that I couldn't measure for an offset voltage over here because the relays clearly are not switching because I have a protect fault. But what I can do is measure here. So where this red and black wire come from the amplifier board, I can measure there to see if I have a DC offset. And if I do have a DC voltage, an offset as it's called, then that's why the protector's on. It's not a fault in the protect circuitry. The protect circuitry is doing what it should do. Yeah. So let's have a look to see if this is the case. Do we have a DC offset on our amplifier? Okay, so we'll power it up. Fault lights on. The clicking relay, I'm sure, is the one over in the corner, the one that just shorts out the, in fact it clicked again, the thermistor. There's something clicking on this somewhere. Okay, so this is one of the channel outputs, and we want to measure to ground. And no, it's like minus 0.004. There's no offset on that one. How about the other amplifier? No, again, there's practically no DC offset. So that would tell me that there's no DC offset on the inputs either. The 1 plus, 1 minus. None on them either. Let's just go to the other point that's marked ground down here. Again, there's no offset there. And we can again, once measuring to this ground from the output of each channel. No, nothing. In fact, it reads 0 now. And the other one is down here, so I have to get to it. Reads 0. So there's no DC offset on our amplifier, okay? During the thought process of that, I've realised why there's a 24 volt connection on here. It's not coming from this power supply. It is coming from here, and that's what's switching the relay. Yeah, the relay needs 24 volts to switch, so that solves that mystery at least. And the last thing, that there were some more test points down here. So channel 1, B plus and E plus. I don't know if B plus means the supply voltage or the base. E plus like as an emitter. Then we have NTC channel 2. We have channel 1 B minus, channel 1 E minus. And then we have this square wave thing. Almost like you're thinking, oh, it's a class D amplifier, but I'm not sure what that really is. No manual for this, no service manual. So let's have a look to see what's on all of these and see whether that really helps us any. Okay, you can see them. So power on again. That really makes me jump sometimes. Channel 1, B plus, plus 74. E plus, plus 74. NTC, 8.65. And we'll compare the two. So on channel 2, B minus, minus 74. E minus, minus 74. And NTC, I think it's that one, 8.7. Same. So that's all the same on the two channels. And then we have the a few more. Yeah, channel 1 B minus, channel 1 E minus. This one, that is minus 68 on whatever that is. Channel 2 B plus, 74. E plus, 74. minus 15 and plus 15. Well, we know we've got them, we've measured them elsewhere. And that's it, really. I mean, not sure what I should have, but what I know I do have is the same on both amplifier channels, which makes me suspect that either there's some fault causing a problem with both, kind of universal to both, or they're fine. Okay, so the 4 AM moment didn't really get us any further, but, well, it was a 4 AM moment. Okay, anyway, there you go. See you all soon, guys. Ciao.